Welcome everyone to the first in the 2020 Responsible AI series after our successful launch of the series last year. My name is Jessica Wyndham and I direct the Scientific Responsibility, Human Rights and Law program of AAAS. We're pleased to be the host of this series and thank Hitachis for their sponsorship. In preparing for the event, we dug into the archives of Science magazine to find what had been published on artificial intelligence, environmental monitoring and sustainability. As you can see in the compilation we've gathered on the series webpage, environmental uses of AI include agricultural yield predictions, forecasting bird migration, and AI as a tool for combating deforestation, amongst many other uses. And today we'll be discussing a range of applications of AI for the environmental purposes, but we would be remiss if we didn't also look at the environmental impacts of AI itself, which we'll be doing later in the discussion. Today, I am joined by Dr. Michael Izat, Chief Scientist for the Industrial and Applied Mathematics team at Hitachis. I'm also joined by Professor Bistra Dilkana, co-director of the Center for AI and Society at the University of Southern California and co-editor of a recently published book called Artificial Intelligence and Conservation. The format of the discussion will be an interview with and discussion among our guests, with time for questions from our audience. So I invite you to post your questions throughout the discussion using the chat function on the right-hand side of your screen. Please include your name and if you'd like, let us know where you're connecting from. So with that, to get started, I want to begin with a question for Bistra. Bistra, could you please give us an overview of the ways in which AI and machine learning are being used currently for environmental monitoring and also sustainability?
Thanks, Jessica. Yeah, indeed, AI has been increasingly transforming industry domains, but what is really exciting to me is that it can also be successfully used to harness our ability to monitor and manage the environment for more sustainable outcomes. So one example is deep learning approaches have transformed our ability to leverage large amounts of satellite remote sensing data that is being collected across the globe now for many years, and we can use it to make more accurate predictions. I have been involved directly in a collaboration with Microsoft AI for Earth to develop new deep learning approaches for land cover mapping. So using AI to quickly and accurately process images from satellites or even from drones can really help many environmental tasks. For example, timely detection of deforestation, as you already mentioned, but also wildfires, even illegal poachers in the protected areas, or, for example, damage from disasters such as floods and earthquakes. And it can also help our ability to monitor and to predict hurricane trajectories and intensities. So these are some of the domains in which deep learning has really already made a difference in terms of helping us build better models than were previously available. Another way that AI is transforming environmental monitoring is actually being able to be deployed in the field inside sensors and closer to the stakeholders that actually need those predictions. So, for example, AI is helping large and small farmers to monitor their crops for like plant diseases and also to make more effective decisions for when to plant and when to harvest, and helping them sustain their livelihoods, increase their productivity, but also decrease fertilizer use. And AI can also help and play a key role in protecting biodiversity, and that's a theme that is really dear to me. So AI is helping in improving distribution modeling and improving data collection through, for example, crowdsourcing initiatives. One very exciting example is, for example, eBird, which is a crowdsourcing initiative that has millions of citizens contributing observations of birds that, together with AI, has transformed our ability to understand how birds migrate, right? So collecting species and observations in the field, though, is often, especially through surveys, is as traditionally done, is very costly and slow process. So more and more places are actually augmenting that with deploying sensors like cameras and audio. But again, collecting only the data alone is not enough, and manually labeling thousands of images or thousands of hours of audio is just not scalable. So again, here AI has been playing a role in developing methods that can help us automatically detect and classify species in images or detect specific word calls in audio, which is really exciting, and it's really helping us understand better species distributions. So one thing that I want to mention that's important to me is that often AI is being kind of equated to machine learning. And while machine learning is a big part of it and can help us make better prediction, it is not the only form of AI that can help environmental sustainability. The area of AI that concerns planning and optimization for resource allocation is also very important. And so a lot of the focus of my work, for example, has been on developing AI algorithms that can help habitat restoration and conservation decisions, where you have to solve problems that have large spatial extents, they have budgetary constraints, complex physical and dynamical constraints. And so finding solutions to those is a real challenge. And so data-driven AI-based decision support tools can actually help with shifting through the exponentially many actions and inform policy and decision makers. Great. So there are many, many different ways, and these are just a few examples, not an exhaustive list by any means.
Thank you. And I'm going to turn to Michael in one moment. We actually have a question that's come in, and Bistro, if you could give us just a quick response. Is there open source AI for farming? This question comes in from Rajesh.
I think so. I'm not an expert on that particular subfield, but I believe so. There's several different initiatives. I know that there is the FarmBeat initiative from AI for Earth, but I'm not sure whether their tool is open source. Okay. Yeah, I don't know.
Okay, sorry. That's fine. Thank you. So, Michael, I'm going to turn to you. Could you talk us through two specific examples of the way in which Hitachi is doing this, applying AI and machine learning to environmental concerns?
Yeah, thank you, Jessica. And the theme is avoidance rather than remediation or even mitigation, which I think maybe conjures up the wrong image and is the wrong metaphor. And so, in industrial scale, every effort begins with a disciplined literature search and a reading of the regulation, including evolving legislative history and even emerging regulation. I mean, public commentary and so forth. So, and we have a very involved governmental affairs directorate that publishes digests and original research and white papers for consumption by scientists and engineers alike throughout the Hitachi family of companies. So two specific examples. One would be proactive equipment platform health, and so to use change point detection to decompose voluminous sensor telemetry to alert and predict future failures, sometimes days and weeks in front of the actual failure event. And almost everyone would prefer to have a nice, relaxing, session to change your tire Saturday morning than to remediate that on the side of the highway. So that the ROI on that is huge. And so to use mathematics and science and engineering to positively influence the thermodynamic efficiency of the manufacture and operation of the target industrial products so as to minimize carbon footprint. Those are our watchwords. And sometimes it's even mundane, everyday tasks, the transportation and purification and heating of water, the compressing of air consumes an enormous amount of energy, but also with the production of the actual work product itself and the thermodynamic footprint, never mind toxic emissions and so forth that must be avoided, not simply remediated or even mitigated. Hand in hand with equipment platform health is workplace safety. And with the proliferation of human-machine interface and accelerators such as robotics and AI-powered or AI-empowered autonomous processes, occupational health and safety are hand in glove with equipment platform health. Secondly would be the predictive and prescriptive analytical capability for design, development, delivery, and operations of optimized industrial processes. So the task is to apply mathematics and science and engineering to craft the analytical data set that captures the data generating function of the industrial process and is predictive with respect to environmental issues. So we work very closely with client subject matter experts to conduct war games to contemplate nearly every scenario, whether it's to avail ourselves of that scenario or to avoid it. And then in the last mile to factor in Monte Carlo effects to quantify the decision under uncertainty that goes with the fog of war at any industrial scale as you apply these from the workbench on through development and QA and deployment into the industrial enterprise. So the theme at Hitachi is that AI does not just stand on the shoulders of disciplined mathematics and science and engineering, but it's intricately woven with them. And I would argue that it's not effective without them.
Thank you very much, Michael. I want to welcome one of our participants here who introduced herself, Larissa Shulkin from Global STEM class in Boston, Massachusetts. And I also want to recognize one of the questions that we've received for either of you, which is a general question. Are AI in these fields only being used by developed countries or developing countries such as those in the South Pacific, among South Pacific islands, also using AI? Michael, do you want to tackle that?
I think there's, so with notable exceptions, and there is amazing science being done everywhere. I myself, just as we speak at this time of day, have crossed about 24 time zones already in my business day, and there are many amazing development groups and scientists in emerging markets. But the point is well taken. The cost of compute for AI can be substantial. The access to libraries and scientific journals is absolutely essential. We believe we start every project with a rigorous literature search, and the answers are not boxed up in statistical software libraries. So the point is well taken, but I think there are some notable bright lights in emerging markets where there are some amazing scientists doing amazing work.
Thank you, Michael. And I think actually Bistra may answer some of this question in response to what we're about to talk about. So I want to talk with both of you about what you see as some of the limitations of AI in this realm. So Michael, starting with you, what do you see as current limitations in what AI and machine learning are able to achieve in light of what you would like it to be able to do, or how you would like to be able to use these tools?
Yeah, and that, Jessica, that's an excellent question. So several years ago, I was in a little bit too public discussion on LinkedIn with a neuroscientist who was rather offended by the analogy that convolutional neural nets, mimic cognitive processes. And his point was that that's not the way neurons work. And so I said, physicists deal with this all the time. You can't just write down the total energy of a glass of water or a cup of coffee or some sheet steel. I mean, you make models, molecules as vibrating springs and rigid rotor tumbling dumbbells and spinning tops, and the observables from those models actually you can see in the laboratory. But he was indignant, and his point is well taken. I mean, our current portfolio of algorithms are the crown jewels of optimization theory, some of them going all the way back to Carl Gauss himself. But despite their power, for many applications, and I'm not speaking at the edge, but in the bulk of industrial investigations, those AI algorithms can't do anything with petabytes of data that a human child can't do with a handful of true positives, and maybe a false positive is a life lesson once in a while if you burn your finger on a hot pot or get bit by a fluffy dog that you mistook for a kitty cat or something. But an actuary can solve those problems with a well-designed experiment, some simple random samples, and some statistical inference. That's the bulk of the application of AI, not at the edges where it's absolutely required and is essential, as Bistra is correctly saying. So don't mishear me. For novel problems at the edge, AI is critical, but that's the technology piece. But there's a human element. I think the metaphor is wrong for AI, and that was the neuroscientist point of view, is that we're working hard, the theoreticians among us, the statistical machinists and quantum machinists, to try to get a different metaphor for what AI can be and could be, and that's the growth area. So it's not clear to me, to Bistra's correct point, that data science and machine learning, as it's commonly practiced, is a science at all. We're somewhat losing our way, and although there's more and more computational power, there's less and less professional duty of care and due diligence. And it's been a long time since programming and IT were formerly computer science, which is, in Bistra's discipline, that sits at the juncture of electrical engineering and mathematics, after all. And information technology doesn't go that far. And that distance is somewhat starting to show, in my considered opinion. And if you add vendors who claim to have boxed up this, this wizard in a box, then the fundamental skills such as design of experiment and statistical inference and confidence intervals and analysis of variance are kind of being discarded for expedience, which allows us to get to the wrong answer more quickly, I guess. But so the community desires explainable AI, and for good reason. In some sense, they've forgotten how to apply statistical mechanics to explain risk when making decision under uncertainty.
Thank you, Mike. I think your point goes to a comment that we received from one of our viewers. Alima Al-Badi mentioned that people's understanding or expectations of AI are probably much greater than the reality. So thank you for that. And so, Bistra, from your perspective, what are some of the current shortcomings of AI and its ability to be used for pressing environmental concerns?
Right. So I guess before I dive into it, just to address the question and some of the comments that Michael made, is AI in terms of exactly some of the maybe aspirations of what it should be, and like true intelligence is definitely not there. But even our current methods for AI are very good at finding patterns in data and finding complex relationships. And I believe for the environmental space, that power is actually very appropriate, right? Where we are trying to study a phenomena that we don't fully understand yet. We maybe haven't gotten the physics or dynamics of it yet, and we want to leverage data and AI approaches to help us get to models that are able better to predict what will happen next than we are currently. So from that perspective, I really believe that AI has a lot to offer for environmental monitoring and management. But obviously, there's many challenges. And one of the biggest wins for AI has been in domains with tons of data. And clearly, in a lot of environmental domains, data is very scarce. So one of the biggest challenges I think AI needs to address is how to develop methods that are able to produce good results with very small data sets. And there are already ongoing research efforts, but the problem is far from solved. And solving that problem, making headway on it, is going to be very important, specifically for the environmental space. And so often we would actually have maybe even access to large amounts of data, but it will be unlabeled, right? So in this context, then the challenge is how do we create approaches that effectively engage humans to label some of the data, but you want to create strategic ways in order to minimize the human effort while providing the most useful additional data to the machine learning model. Excuse me. And so there's definitely open questions there. And human AI collaboration techniques in developing predictive models for environmental tasks, I think, will be critical in solving data scarcity problems, and also in helping us leverage the deep domain expertise that ecologists, biologists, and environmental scientists have. So that's one, really figuring out how to create AI methods that can work with little data. And back about the developed versus the developing countries, that's another thing. Maybe in developed countries, for the same environmental task, we might have tons of data, and in other places where instrumentation has not been that advanced, maybe the data is very scarce. So how can we create models that maybe can leverage some of the big data in other places, and maybe fine-tune them with the small data that we have in new places without biasing the models too much, such that, they're predicting stuff that doesn't even apply to this geography, for example, right? So this, generalization to new spatial regions, to new places is very important, again, for environmental tasks. Another way that the data scarcity problem, as well as the other problems of have and have nots that can be solved, is by establishing better methods to share data and to share models, right, across the community. So again, for example, the land cover mapping problem that I was engaged in, we did that for the US, but we cannot just take that model and apply it to other places. But yet, if we provide it in an open source way, then others might be able to take it and specialize it to, their own country. So this problem of silo of data lying with specific organizations and individual researchers, and now more and more as AI techniques are entering the space, even these models that we've trained using lots of data and lots of compute resources being with specific organizations, is a big problem. And so I know that the UN Environmental Program is, for example, actively thinking about how to establish better frameworks and pipelines for data and model sharing, and that solving that big challenge is going to dramatically help us improve the footprint for environmental monitoring and sustainability. Right. So another thing that that I already mentioned is the compute resources. So training some of these models is very expensive, but also sometimes running them. So if we're going to be sharing models, we also have to be thinking who is going to be using them. If there's, for example, a small national park that has, a small office with an old laptop, can they use the ML model there, right? So we need to think about, again, AI approaches that will let us also generate models that can run on limited compute resources. And so that's the other big challenge that I see.
Thank you, Bistra. So we have a question here, which I think is probably best directed at Michael, coming from Karen Peterson, who asks, can AI be used to track the rail industry and pollution from railroads? Transportation is one of your areas, Michael.
Oh boy. Yes, and I'm actively engaged in that. I wonder if our viewers are aware of the positive train control legislation. I'm not an expert in it, so I don't want to make a fool of myself, but the basic idea is that the federal authorities basically throughout the Americas, certainly in Canada, the United States, are kind of done with rail accidents. If you have to have an accident, you can't be a railroad anymore. And so this touches every aspect, certainly equipment platform health, as I mentioned, the fatigue of crews, the predictive maintenance and scheduled maintenance on equipment, sometimes when gremlins crawl into the equipment days and weeks and months ahead of the failure itself. And so it precedes reliability engineering by many scales of the characteristic constant. So rail and transportation of all sorts, certainly truck networks, car networks, maritime, rail. I've touched everything except air in my own career. Can avail themselves of AI algorithms, but I have to agree with Bistra completely and implicitly. The algorithms are fairly stable. There's new research all the time. Don't mishear me, but many of these techniques have been very stable. At least for the last 20 years, and certainly the last 10 years. But the data is very expensive to acquire, and it indeed is a public good in many cases. That's a personal opinion and a professional opinion. I think there's a role for government. I think there's a role for information security as private business can submit perhaps their own data sets as a public good. It would have to be redacted and scaled and so forth, but there's a way forward with that if you talk to information security professionals, such that private business and large public accommodations can submit data for large data sets. But indeed in agriculture, in environment, in astrophysics, in oceanography, certainly in transportation networks, it is extremely expensive to acquire such data. And so that is always going to be the rate determining step for the next many years. But I do know many scholars are actively working on that to solve that from a technology information security point of view, but also public policy professionals, Jessica, are actively involved in that.
Well, Michael, we've one of our viewers has excuse me, leapt ahead of me, but asking the question that I next wanted to pose to you, but I'm going to frame it the way she does. Tanya Berger has asked, how do we take into account the environmental cost of AI and machine learning itself? So, Michael, if you wouldn't mind addressing that.
Yeah, and I wanted to make clear I was not in, and I accept Bistra's advocacy for AI. I certainly am not indicting or impugning the efficacy and power of AI. I use it every day and lead a professional group, but it needs to be understood that these algorithms are and computational devices that are required to realize the promise of these algorithms are extremely large carbon footprint. And so part of what we do at Hitachis, we try to be mindful of that. We start with a number 2 pencil in a scientific paper. We're very slow to leave the pencil and paper to go to a CPU, just a laptop computer or a server. We're even slower to go to a GPU. Remember, training a fairly large vector for a computer vision model or something of that nature reduced sensor telemetry can use about as much carbon as 5 cars in their entire lifetime. Sending an email simply with an attachment would have a carbon footprint that would probably shock your conscience. So the notion that we're a green industry, I think, is a stretch. And so the only way we can be mindful is to assert positively that listen, AI is first and foremost a statistical and engineering and scientific discipline. And before you simply spin up some processors to solve something you could do with a number 2 pencil, you should think twice. And indeed, professionally, that's exactly what the applied industrial and applied mathematics team at Hitachis is for. We are the folks who dive in and do the science before we hand it to our big data analytics folks to code up and run, not only for test and QA, but then finally into production for production benefit. And then secondly, I would say that there's a section on the engineering exam, it used to be anyway, Jessica, the professional engineers exam, called engineering economics. And I think it's fair to require that we calculate the ROI on AI. It's not a video game, it's serious stuff. And it's fun to do. It's astonishing to see those answers come out on problem sets that were absolutely intractable at the edges before. But there is indeed, a very small ROI in the bulk of investigations. At the edges, it's phenomenally positive. But when AI is applied where it needn't be, the ROI is almost certainly very negative.
Thank you, Michael. We have 4 minutes left in the event. We've had a lot of questions come in. Several of them relate to the relationship between AI and society and trust and understanding and so on. So I'm going to give each of you 1 minute to share any last thoughts or comments that you would like. If you want to pick up on the AI public interface, you're welcome to do so. But if there's anything else that you'd like to add, please do. Bistra, I'll start with you.
Right. So actually, one of the things that I didn't get to say with the AI and the users of AI, right? So it's very important to develop methodologies that will allow for the users to be able to to understand the models, to build trust with them, and to interact and maybe even change how they behave. And so that's actually one of the big open questions about interpretability, explanations of machine learning models, but also providing somehow user interfaces for the people that are using them to influence the model and give feedback about some things, for example, that don't make sense or need to be improved because of domain knowledge that they have. And the second aspect that I really wanted just quickly to mention is about education. So for AI to make a big impact, we also have to understand the fact that, first of all, we need to develop the abilities of AI more equitably across the globe and put it in the hands of people that need it. And also have more people that are interested at this intersection of AI and the environment. And there's 2 ways to do that. One is to be able to educate people that are in NGOs, environmentalists, farmers, and so on, for them to be able even to be thinking about building their own AI solutions. And the other one is to take more of the computer science and people students that are interested in pursuing these careers to actually deeply care about environmental issues and see how AI can be applied for the environment. And very passionate.
Thank you. Wow. I want to make sure that Michael has his chance. We've probably got about 45 seconds, Michael. So if you've got last minute thoughts to share, please do so.
I'm pleased to give Bistra the last word. I would just assert that the data generating function is the important thing. AI is not inherently good or bad, but it is fair to ask what assumptions are in the analytic data set that is the starting place for AI or machine learning or even statistics itself. And so society has a right to ask those questions, and I think investigators have a duty to disclose the analytic data sets that inform their statistical inference.
I appreciate that. Well, I want to take this opportunity to thank you both, Professor Bistra Dilkana and Dr. Michael Izat, and to Hitachi for sponsoring this event. I hope that all of you will join us for the next in this series, which will focus on artificial intelligence as a tool in medical triage, particularly during the COVID-19 pandemic. That discussion will be held here on the same channel at the same time on November 12. And in the meantime, do take a look at the series website for Science Magazine resources on all topics that we've covered. So thank you again to our participants, to our audience, and I look forward to seeing you November 12. Thank you and stay well.